Hello everyone. How's it going? Welcome, welcome to the stream. It's been quite some time that I have streamed, almost probably 2 or 3 weeks. Yeah, it was festive season, Durga Puja time, so I had a lot of fun with family. So I kind of didn't stream at that time, and after that, kind of life happened, and yeah. So today also I was not planning to stream, and then I thought that I'll start from next week. But yeah, I mean, I've been planning for a couple of things that I'm gonna stream and things like that. And it became late, and I thought, okay, maybe let's do a quick stream because of the fact that my entire OBS got messed up, so I had to set up everything from scratch again. And I'm hoping so that the setting is working correct now. I'm really hoping so. Okay, so yeah, welcome to the stream. Welcome to the stream. How is everybody doing? Hope you had a great festival, and hope you have a great Diwali coming forward. Looking forward to Diwali, really good. Yeah, and how have you guys been doing? How's it going with you guys? As you can see, there's been a little bit of change in settings. So my old table is now there, there, right there behind me, and yeah, I got a new table, so now the space is better, and I can work better. That's one thing. The old table was not that much of a spacious thing. I still don't have two monitors. I'm still kind of against having two monitors, so I have my phone here for uh, chat. But yeah, let's see. I still have no plans for having a second monitor. Do I have plans to connect my Mac? I have a KVM machine, so a KVM switch. So yeah, it's pretty good to quickly switch over things. So sometimes I connect my office Mac, but maybe I'll connect my personal Mac, but not quite sure. Yeah. Anyways, welcome to the stream, everyone. Thank you so much for joining. It's already late, but I was not sleepy. I slept throughout the evening, and then I was working on things where I was planning where I really do want to take this channel and what kind of content do I want to work on. So I was planning a couple of things, and yeah, for that particular thing, you have to wait a bit for a video to come out. Probably I'll make a video. So I planned for a complete live stream, and then I thought, okay, maybe I'll start doing videos now, and it kind of makes sense more. I feel kind of makes sense more. So maybe there'll be an introductory video on what's the next project that I'm going to take up. This is one particular project which came in my mind, which is not kind of like toy project. I feel it's really going to be useful, and that's why I'm going to start working on it. And it's also one more thing where I can explore new technology. So that's one thing. So yeah, let's see. Fingers crossed. Probably in some days I'll just quickly make a video. Maybe tomorrow I'll record it. I have been skeptical about recording videos. It needs to be perfect. It needs to be this. As you can see, my camera is not in my eye level and things like that. These kind of things bother me. But then I just thought and told myself, why should I? Why should I bother? I should just put it out and then see the reaction and get as feedback. And second thing, even if I like, it kind of becomes like the entire point of YouTube was to document my journey as a software engineer. I have 10 years of working experience. I honestly feel I'm nowhere around to being even like 20% of a really good software engineer who is solving problems at large scale. So I want to document my journey where I'm trying to go there. So it's going to take some time, but I need to know if I'm improving over time. Small piece of code I write is improving, if my thought process is improving or not. So I just said, okay, why not? Let's start somewhere, and then if I need to improve it, if I need to do something about it, we can think about it, right? So yeah. Before we move forward, I hope my audio is good and I hope my video is good. So as you can see, there's been a little bit of changing in the light also. My old photographer brain is coming out a little, so I hope this setting is good. And yeah, I hope you guys like it. It looks good on my screen on my this thing. One of the things YouTube does it actually streams at 720 automatically. I'm streaming at 2K. Just give me 2K wise. Hmm. Yeah, I feel this setup is kind of more dramatic and it feels good in my opinion. So I'm just gonna look like this because right now I'm seeing myself just looking at the phone, and that kind of makes stupid. Yeah, I feel the slide is good. I feel the slide is good, honestly. It's kind of dramatic and everything is good. Cool. Okay. Yeah, I'm gonna do some more changes to the stream setup. Slowly you'll have a live chat overlay, things like that. And I know I have already signed up for Stream Elements or Stream Labs. I don't remember which one. Probably I signed up for both. But yeah, like which one does that overlay thing, I don't remember. But I was thinking of just writing my own things and not relying on them to keep working. So I was thinking of just writing a backend server which keeps on polling for chat and then keeps on polling for your subscriber count and things like that, and see what kind of interesting things we can do. So yeah, a lot of things in the plan. But yeah, hopefully things go according to plan, right? Fingers crossed. Fingers crossed. Okay, cool. Without any further ado, I think we can go into some discussions of what we are doing tonight. So since I was not getting good sleep, like I was not feeling sleepy specifically because I slept quite a lot in the evening, and then I was kind of like, sucked into this thing where I was trying to think about where I'm going to take the channel, how I'm going to do content, things like that. Sorry. So in that particular case, I was thinking that, hey, um, what is like I mentioned, OBS got messed up. So I said, okay, let me quickly go ahead and create a new stream and see that, okay, whatever settings I have done is all good. So I hope it's all good. Yeah. So what I'm gonna do is I'm just gonna put everything on mute, and I'm gonna take a quick break. I'm gonna refill my water. I didn't refill anything before that, so I'm gonna take a quick 5 minutes break. So I'm gonna take a quick 5 minutes break, and yeah. After that, once I'm back, what we're going to do today is recently I have been doing some problems from Neetcode, and I am planning and I'm thinking to actually complete the roadmap that you have there, and I'm planning to do it live. So yeah, after I'm coming back from the break of quick 5 minutes, I'm gonna quickly start iterating over what exactly we're gonna do and all that. And while I'm on break, I'm just gonna hear everything on my phone, that if the audio and things like that are okay and good. Okay. Yeah, so I'll see you in 5 minutes. Thank you. and welcome back. I'm gonna put the music a little bit slow because I think it's too loud. Not for me, but for the viewers. Okay, so what are we doing today? Well, since it's already late and I don't know how long I can stream, probably like an hour or so, I thought, let me complete the Neetcode roadmap. Okay, so I'll go to my live stream, live scene. Yeah, everything is closed. Awesome. Cool. So, this is the roadmap, and I've already completed, I think, 90% of the stuff. So yeah. From the blind 75, and then I saw something interesting today. Saw that it turns pink when I complete something. So as you can see, trees I have not completed, so it's like a progress bar. So this is not full yet, and that's what I want to get now, because this is a new dopamine hit where I try and get every one of the nodes in this tree pink. Okay. Some of them I already have doubts with, because I know that I cannot do so much. Like I have to still look up some of the things, and I almost have I have exactly 80 problems to go through. Okay, but before that, I want to do something quick. Okay, because now I want to make videos, so I want to cut it out. Okay, from this thing. So probably put the music a little low. Okay. Hello everyone. Hello. Welcome to the Algorithm Hour. Algorithm Hour is a series where I hope so that I'm trying to make it a long-running series. I previously have done so, but I'm trying to rebrand it in a different way. So I'm not going to call it Day 0 T1 anymore. I hope you get the Day 0 reference, by the way. If you're a software dev, you will definitely get it. But as you can see, the thumbnail has also changed. But here is what I'm trying to do with Algorithm Hour. There are going to be live streams where I'm solving algorithms. There are going to be live streams where I'm learning new algorithms and implementing them. I'll try to read through some white papers which is related to algorithms. I'm going to be trying learning new algorithms, specifically things which are more advanced. As an example, algoexpert, something which is helpful for string matching, and why use that and why not use KMP? Why use Bourme, something like that is there. So these kind of things I'm trying to implement and learn. The idea is that so as a senior engineer, I feel, again, people can say that why do DSA? The only reason why you need DSA is if you're solving problems at a larger scale, you need to have the knowledge of these things. That is what my opinion is, by the way, and I think it's the opinion of every good software engineer in general. If you do not understand, if you're a mechanic and if you do not know how to use a certain tool, you are only bounding yourself to use a wrench and a hammer. You don't know how to use some other tool, right? Which is at your disposal. You could have just simply asked someone or look up and learn how to use that tool and use it in a better way in situations where it is required, and it's a better fit. I feel it's the same with algorithms and data structures. If I'm not aware of a certain data structure, I would never be able to suggest it for a problem to solve where it's a good fit. So lastly, I was looking at one of the examples called Bloom filters. Bloom filters are nothing but hash maps. But if you have a constraint on size, it kind of gives you a probabilistic thing. So instead of an actual hash map, you would use that. But if I never actually know Bloom filter and I'm actually trying to solve a problem where I come up with this constraint that I have constrained memory, I would never be able to suggest a Bloom filter because I never learned about it. So entire algorithm hour is gonna be about that, where I'm learning algorithms, where I am implementing algorithms, reading more things, and hopefully it's gonna be a long series because you can never stop learning something related to algorithms. And sometimes, mostly on live streams, I don't plan to make videos honestly, but maybe at some point. Uh, I'm just gonna go to some interview like platform like LeetCode, Neetcode, algoexperts, and things like that, and solve some problems and grind through some problems. Again, it gives a dopamine hit if you're actually getting that green tick. Like I mentioned, for in this case, why I'm doing Neetcode today is because I just realized today that once you finish off one of the groups, it basically turns pink. So, oh, something is changing. So why don't I finish it off? So yeah, hopefully it's gonna be a long series, including videos, including live streams, and hopefully also blog post. So I'm gonna try and take content creation more, seriously. And the most important thing is, I feel this is more about documenting my journey and where I go from here. At some point, I can look back a year, look back 2 years, look back 5 years, and I say, hey, I was here, but I'm here now. Like, it's really good. Another dopamine hit, I would say. So yeah, I hope you enjoy the series and keep a lookout on the channel. Do subscribe, do like, and do share with people who are interested in these kind of things. Thank you. Okay, so now that I've hopefully done a video which I can cut, I think let's get into some algorithm grinding at 1:30 in the night for India time. The awesome time to actually work. But yeah, okay. Cool. I'm gonna lower the music also for myself a little bit, and if someone is watching me right now, just put it on the comment if you feel that the music is too loud for you guys, and I'm gonna reduce it more. But I think I already reduced it quite a bit, and I hope my voice is crisp and clear. Okay, let's dive into it. So the question here is, what do I start with? So I have only tries as pink. And basically I completed everything under tries. That's a good thing. So I feel that array hashing is only left one. So let's try and start off there. And then I think we can go to intervals, where minimum interval to include each query. Oh my god, sounds already like a tough one to crack. But let's see what all things, other things. Bit manipulation, I have 2 left. Okay. Maths and geometry, I hate these kind of things. Specifically geometry. I was really good at these things when I was in school. 2010, so 15 years back. I was dumb enough not to keep continuing these things in college. I should have, honestly. But yeah, whatever. Hopefully we'll be there. So let's do this. Okay, valid pseudo. So what's the problem statement? The problem statement is, you're given a 9x9 Sudoku board. Sudoku board is valid if the following rules are followed. Each row, okay, the standard rules, right? Each of the 3x3 should have 1 to 9 without duplicates. Return true if the Sudoku board is valid, else false. A board does not need to be full or be solvable to be valid. What does that mean? Okay, I get it. So you only work with the given data that you have. You do not have to solve. You do not have to figure out if it's actually solvable or not. So maybe even though it is valid looking at just the numbers that is present, but it's an unsolvable board. So somewhere there's a mistake which is unsolvable, but we don't care about that. What we really care about, is with the given data, is it good or not, right? That's the only thing we care about. Okay. So, So I know this is one of the more tricky problems, where you also have a problem where you have to solve a Sudoku board, and I never actually did that. So yeah, I think it's a good time to actually solve this guy. Oh, I actually solved it before. Wow. I wonder how I solved it. So we're gonna solve it and then see how I solved it before. If it's the same way, I guess we have to look if there's a better way to solve it. Okay. So it's all strings that is given to me, and if it's empty, it's basically a dot. Okay. And so okay, the constants, its length is 9, board is 9, and then you have I is a digit of 1 to 9. Okay, so there can be no invalid digits as in like 0. And what about negative? Somebody can put in negative things. I mean, it's obviously cannot because it's yeah, it's character. But if you're doing in something which doesn't have character and has strings, that is gonna be a problem. But I think for us, we don't care because it's always 1 to 9 or a dot. Dot means it's an empty thing, and then 1 to 9 is basically a character, right? A digit. Okay. So since the board is always a standard Sudoku board, which is 9, which is 9 cross 9, I feel what you can do here is it is not about the time constraint. It is always about the time constraint is bound by how quickly. So the entire idea is that you go over each row and you go over each column, and then somehow I have to go over each of the sub grids or sub matrices and figure out if they are correct or not. And the challenge here is to look up that there should be no duplicates, and that should be enough to say if the board is valid or not. Okay. And the only challenge here is that how quickly can you look up if it's a duplicate or not. And for that, you can use a set. So that's one thing. You can simply use a set. But since we have bounded length here, 1 to 9, like everything is 9 cross 9, and here also there will be 9 values, we can simply say, hey, why don't we take off that, just make the set naked. What I mean by that is I can use a array of length. Let's just use 10, just easier for us to simply look up the index. One space really doesn't make a difference, right? Really doesn't make a difference. So you can simply look it up. So that's pretty much it. We can use an array for it. In fact, instead of using an array, we can use a mask. It's called a mask, right? It's not called it's just whatever. So you can only have 9, and a short is 2 bytes. So we can simply use a short. I mean, we can simply use an integer. It's not going to be any issue because it's always going to be allocated on the stack for Java. We're going to be using Java to solve this problem today. And most likely I'm going to be using Java to solve a lot of problems because I think I'm over that phase where I keep on switching programming languages and have fun saying, oh, I can solve this in Go, I can solve this in Python. I don't think so it makes sense anymore. It was fun when I was learning new languages, but even if I'm out of that phase. Anyways, so let's do a quick thing in here. Okay. So let's do a quick thing here, and yeah, so what you can do is this thing, and then here is 1, 2, 3, 4, 5, 6, 7. We gotta shift stuff now. 2, 3, 4, 5, 6, 7, 8. And then in here, 1, 2, 3, 4, 5, 6, 7. Okay, so we have a 9 cross 9 sort of board. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4. Zero, 1, 2, 3, 4, 5, 6. Why did I mess it up? Not quite sure why I messed it up, but okay. We can simply 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So let's quickly see it. 1, 2, 3, 1, 2, 3, 4, 5. Man, that's tough to remember. 4, 5. 9, 8, and the last one is 3. So 5, 6, 4, 5. Then you come in the middle 6, and then this is 4. Then you have 8, 3, 5. Okay, let's choose like this. 6, 6, 8, 3, 2. 4, 5, 6. There's nothing there. 4, 1, 9, and 8. 4, 1, 9, and 8. And then you have 2, 7, 8, 9. 2, 7, 8, 9, like this. So I feel what we can do here is that, like I mentioned, we can take a short or we can take an int. So there's gonna be, let's say we take an integer and there's gonna be 32 bits in here, but we only need 9 of those. So 1, 2, 3, 4, 5, 6, 7. So in here, what we're gonna do is we're gonna first iterate over each row. So like this. So we're gonna first iterate over each row, then we're gonna iterate over each column. Then we have to somehow iterate over each grid, right? I think this is the more challenging part, where you iterate over groups in 3. How do you do that? Well, I think you can simply say you take in groups of 3 for both the cases. So rows is equal to 9, columns is equal to 9. So 0 to 2, 3 to 7, 8, 9, 6, 7 to, well, that is wrong. 3, 4, 5, 6, 7, 8. This is how you can do. And a similar way, your rows and columns will both change. So what I can say in here is that you start off row count at 0 and plus equals 3, column equals 0, column plus equals 3. So it skips over, and within this, so there's going to be 2 loops, and within that we can have a loop which says, oh, just iterate from here to plus 3. That should be it. So even we'll have 4 nested loops, but it's still gonna be O of n, O of m into n, well, O of 1 technically, because of the fact that you always have 9 cross 9 Sudoku board and nothing else. So that's why your value would be amortized O of 1. And there would be no extra space because we are using an int as a bit field. We are not using an array, we are not using a set. And since we are using integers, we can assign as many as possible. It really doesn't matter. We can always reset the values to 0 before we actually start counting for the next thing, whatever is there, right? So that is what the entire thing is. Yeah, so that is the way forward. And I'm going to go ahead and do that. So valid Sudoku. I wonder if I actually, okay, so I have to open up this thing. Okay. Scale is not coming up, so let me, oh, it's called zoom, that's why. Okay, so yeah, valid Sudoku. Okay, so let's quickly grab this guy in here. My chair is a bit off. Okay. what I want to do here is also it's characters and not numbers. I mean, probably because you want to, okay, we have to make sure that we skip over the dots. So we are not going to add any validations. I'm really sorry, excuse me. We are not going to add any validations because our constraints are given in such a way. Ideally speaking, in your production code, you want to add such validations, right? But yeah, okay. So in here, private boolean valid rows. So you can simply say that. And in here, in rows is just saying, look at that, auto completion and stuff like that. So that's pretty good. Then what do you want to do? So this is valid rows. So here I want to go in this direction. For int column is 0. So now what I can do is, so this is happening for my bad. So this is every row, and then this is gonna be rows, right? So this is gonna be rows in here, and then after that I'm gonna say int I'm not quite sure what is it called. This is ChatGPT quick. Int bit manipulations we have masks, and another one which is extract one layer below array. What is it called? Bit field? I just completely don't remember what. Excellent question. Just give me the answer, bro. It's called a bitmap. I completely forgot. It's called a bitmap. So yeah, bitmap should be equals 0 for int. Look at that. So if this is this, I'm simply gonna continue. Otherwise, what I'm gonna do is int I should be board of row column minus 0. Now we can say 1 because we are 1 to 9, right? So we can say that. Once we have that, we can simply say key bitmap shift right shift by I if equal to 1. We're gonna return false, right? Otherwise, we're gonna say bitmap equals bitmap, or that's exactly what we want to do. And that's pretty much it. And for every iteration you do that, and here is return true. Valid columns. So in here you first go over, well, column. So this is columns. Then f6 is row. Let's refactor. It's back to column. So of course we have to change this. Okay. So this is valid. This, of course, this is wrong because it has to be rows. Well, why don't I even just simply, because I know for a fact. So it's also going to be a good assertion. It has to be 9. This has to be 9. Private boolean valid box. Look at that. It actually knows what you're talking about. But in here, row plus 3, column for so now we're inside the box, right? So what I'm gonna do here is bitmap is 0. So int r, I say r is gonna be row, and r is gonna be less than row plus 3, and this. So this has to be C, this has to be column plus, this has to be column. Yeah. If this is this, -1, if bitmap right shift is this. Okay, so it pretty much done its job. So in here, we can simply say valid rows and valid columns, and is valid box. Run. One thing I quickly want to do here is valid rows, is valid columns, is valid box, and that should be pretty much it. So let's actually see if we are good. Hopefully we are good. Yeah. Awesome. The second one actually failed. So we should be good here. Great. What happened? So your output is true, but it has to be false. Why is that? So this is false. Okay. Why is this false? That's the question. Oh my god, this color is... Okay, this is better, I feel. So let's actually do this thing, because I cannot read shit among 15,000 things in here. So 1, 2, and you have empty spaces, and you have 3, then you have 1, 2. Wait. This here should be false. Okay, so I feel the box is not correct. We always reset after we come out of this box, right? That's when we reset it. So first it would be this, then the column would shift, so it would go to the second one. Yeah. There are 2 ones in the top left. Yeah, okay. So why did this not actually work? Because this is kind of sus, I feel. Because I'm an idiot. So I'm gonna have to replace this width and 1. So let's quickly go ahead and say class solution. Okay, awesome. So I feel that should be the answer. But the question here is that we wrote a lot of code for nothing, and I'm wondering if I wrote the same kind of code with Python. Let's actually see what I wrote, because I wrote this almost a year back, more than a year back, 1.5 years back. Oh no, I actually wrote, so 12 is the date. Okay. So I wrote it exactly a year back. Let's see what I did there. Okay, so for row in range of 0, bitmap is, I did a bitmap. Okay, and I called it a bitmap. I did exactly the same thing. Holy shit. I did exactly the same thing, and you can do inner functions. So I did inner functions in here. In fact, here also I can do inner functions, by the way. Here also I can do inner functions. One of the ways would be to actually create predicates. So you can create predicates and return them. So you can still do inner functions in here. So you can tuck all of these things together in here, where you define them as predicates and blah 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 and all of that. That is not the point. And with Java, any other programming languages, mostly with Java, it's going to be a little bit slow with that method, because then you would be wrapping things around and things like that, which I don't want to do, of course, because it's not going to return a Boolean primitive. It's going to return a Boolean this thing. Things like that. This one can still be taken care of, because it's not like it's already an object type. But yeah, whatever it is, what I do want to see is if I can do some sort of a thing in here. Because the first thing you see in here is these two functions are exactly the same, except the fact that here you iterate over row first, then you iterate over column first. And everything else is the same. So the only difference here is that in here you go like this on the right, then you come down, and here you go like this. This one is a little bit off. Question here is how I can tuck these things together in a single function. So one of the things I can always think of is you pass in the row and the column, and if you pass in the row and the column, you can always be like, okay, like change the way you forward the arguments. That should be it. That should be one of the ways to do it. Sorry, that should be one of the ways to do it. One of the ways is you always keep the iteration the same, but you just change this. So here, if I say A and B, you say so you say A and B, and for the other method you say B and A. That's pretty much it that you can do in here. That's one of the things that we can do. Int row from, int row to, int column from, this thing. So in here, instead of this row from row 2, and then this is gonna be column from column 2. Okay, so I want to delete this, and so let's call it check 0909. What is the difference in here that you're doing? No, 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 no. You cannot do that because we cannot pass it in which kind of way that we're gonna test. So it's a bit sad in it, sorry. Let's ask ChatGPT. Looking at this solution, feels like we can refactor into a single method which accepts some sort of arguments to understand how to iterate and from an end constraints. Otherwise, it's a lot of repetition. Oh, can we compress this by refactoring it? That's the real question. This is exact. Oh, cell provider. This is another function. Okay. Oh, that's pretty interesting. That's pretty interesting. Okay, what exactly is it doing? So you have functional interface for which when you give ing, it gives you a cell, gives you a row and a cell. Okay, a row and a column. Okay. So the outer and inner bounds are always 9 and 9. So from wait a second. No, it's not always 9. Wait, it's always 9 and 9. We have something called a cell provider, which also means right here, this code is going to be a little bit slow. This code is going to be a little bit slow with memory allocation and things like that against your cell provider. So one of the things we can do is called volt and so oh, it's holy shit, it still has my code. Oh, good for you. So if I just take this, let's say, and in here I think we have to delete this kind of stuff. Maybe we have to do this. Yeah, that's pretty much it. So the question here is how many lines of actual code that we have got. Well, let's take some white spaces into consideration. You have almost 206 things, even with JDK 24, where we supposed to be. So I think 25 came in. Is there 25 open? No, it's not there yet. So I'm guessing they're gonna do some sort of update soon. But the bigger question here is, what if I copied this? So it's a 206 lines of code where you have 2, 4, 6, 8, 9. So you have 9 lines of blank. So it's 197 lines of code, if I would say. But now, what the heck? What the heck? Error, cannot find symbol JDK. What are you talking about, bro? Okay, so maybe we go down. I can still complain about that. Okay, so something is off in here. 24. Oh, okay. We can actually. Okay, it's actually the other way. How is it sorted? I don't know. Ah, sorted in lex. Okay. Anyways, so why is it saying cannot find symbol JDQ? What did I copy paste? Did I not copy paste the correct thing? I copy pasted the correct thing. It has to be. Is it not compilable? Did you shithead give me a code which doesn't compile? Wait. I get it. So where? Okay. Are you happy now? You're still okay. Now you're happy. This wins. This wins. 161 lines of code where there is 1, 3, 5, 7, 9. 11, 12, 13 lines of code missing. So 161 minus 11 is 50, minus 2, 48. Okay, so this is kind of the winner, but the question is, will it actually, run on a faster this thing in here? So, to do. Below is the functional compact implementation of this. So yeah, we need to do profiling before we start hitting on functional and oops. Don't be a oops moment. We have to do a profiling before we start shitting on anything, right? Okay, if I start profiling, it would completely, I think it would fall back to, so I forgot the name of the tool that I use for profiling. Shit. JVM performance tools, not JMeter and things like that, guys. I'm talking about library. Parfait is one of them. I'm not talking about that. Man, what is it called? Micro. And constantly I'm getting JVM in my head, but it's not JVM, it's something else. Micro profiling. So it's usually called micro profiling. Damn it, dude. How can I completely forget? Is this what I have to look for? I didn't know this actually. Java can generate data which is recognized by flame graph. Wow, okay. I actually have to look into this thing again. Okay. Yeah, so you have perf. So this is a pure low level this thing in here. So preserve frame pointer. Okay, so this is something which is very specific in here. I'm not talking about that. I'm talking about Java micro profile. Profiling library. There's something called a black hole. Java black hole. GMH. Dude, it's called GMH. Yeah, it's called GMH. Yeah, this thing just went off my mind. So maybe use GMH to actually profile this thing. And I didn't know about this flame graph, but flame graph is more like understanding your bottlenecks and where exactly your performance is getting a bottleneck from. I don't want to do that. I want to compare two different algorithms with a certain fuzz input and see exactly what's happening. Okay. Specifically speaking, I also have a little bit, show off. I have 4070. That's not going to be helpful in here, but I have a 7800X3D, which is one of the best processors that you can get there, CPUs, motherboards that you can get there. With the motherboard, I'm saying the chipset you can get there. Along with, it doesn't show. What the heck? Oh, 64 gigs of memory. So look at that. I have 64 gigs of memory right here. Yeah, before this I was always working with 8 GB stuff, but yeah, it's really a blessing, and now I feel it's an overkill because now your CPU, see, I'm still streaming at 2K and it's just 1.3%, 1.2%, but it's really fun. It gets not overloaded, it gets still the full when I switch to Windows. I have Windows installed and it's purely for gaming. I do nothing else there, and I also am using it for video editing because DaVinci Resolve actually works there. It doesn't work on my Linux. The day I can make it work on here, I'm gonna just say bye to that. So that's gonna be purely for gaming. So anyways, yeah, coming back to the point, right? So okay, so we did at least one problem, and I see that this should be pink now. It's pink. Awesome. So let's move on to 2-pointers. Should I move on to 2-pointers, or should I try and find something which is more like, yeah, let's do 2-pointers because I feel we can get that done. To sum, to input, I've done these kind of problems before, and I think we can just simply go ahead and do it. So we'll quickly go over this problem. Given an array of integer numbers that is sorted in a non-decreasing order, non-decreasing order means it can be same or it can be greater than the next one. Return the indices 1 based of two numbers such that they add up to a given target number, where this is less than this. Cannot be equal, therefore you must not use the same element twice. There will always be an exactly one valid solution. You must use a, yeah, so in this particular case, since it's already sorted, you can use 2 pointers. So as an example, there's only one example here. So there's only one example here, but yeah, that's fine. What you can simply do is you can have a pointer here and a pointer here since it's sorted. So I can say, what is the sum of this? The sum of this is 5. Now 5 is greater than 3. Now since 5 is greater than 3, how can I make this target come closer to 3? The only way to make this target come closer to 3 is by saying, hey, why don't I try adding a smaller number? And what's the best way of doing that? What's the best strategy of doing it? Well, we have 2 pointers, we have to move one of them. The best strategy would be to move away from the bigger one because I have to reach a lower target. So why don't I try adding something low? So this is 3. And at this particular point, I'm going to say, okay, this is 4. So it's still bigger. So I'm going to move this guy and it's going to come to 3. But let's say it was an hypothetical 3.5. Just consider 3.5 as an integer for now. So once it's still bigger, it's gonna come here. Well, I didn't want to do that. Let's call it 4.5 because once you come here, it's gonna be 4, right? So now you're gonna say that, hey, 4.5 is greater, so I need something bigger to try and match it up. So that is when you would move this pointer. So if it is equal, you have a hit because it's going to be exactly one solution. You can simply return that right away. If you have less than, then move the left pointer. If it's greater, move the right pointer. That's all. That's basically it. It's a very, very simple solution. Do we have any no copyright music for YouTube? Okay, so let's see what exactly is playing in here. Oh wow, how does it know? How does it know that it has to be +1? Is this motherfucker listening to me? I mean, okay. Okay. Oh wow, I solved all of these problems a year back. Trapping rainwater. So you're given an array of non-negative integers heights, which represents an elevation map. Okay, some sort of a, not heat map, but some sort of a histogram, right? Each value heights of 5 represents this one also. I probably solved the entire Neetcode thing last year. I just don't remember. Wow. Okay. So each value represents the height of a bar, which has a width of 1. Return the maximum area of the water that can be trapped between the bars. Array of non-negative integers. Array of non-negative integers. Okay. Which represent an elevation map. Each value heights of 5 represents a height of a bar, which is a width of 1. Okay, so of course you cannot have anything on the other side, right? Here the anyways is 0, but even if it had 10, there can be nothing in the first and the last height. The question here is that what is the amount of water that will fit on top of this thing? Sorry, on top of 2. I want to say next greater height on the right, that would be the bound, and the next greater height, but that is not quite true. Because if you see on the rightmost, if I have something larger in here, that would be the bound. Yeah, that would be the bound. So it's not just next, it's whatever is the next greatest. So next greater could have been solved with a stack. We cannot do that in here. So so far so good. Good music. Like it. So if I just do a running thing in here from here to here, right? So what is the max height in here? 2. What is the max height in here? 2. The max height in here is 3. What is the max height in here? 3. 3. 3. 3. So in here I want to make 13, 13, 13, 13. We don't care about this honestly. So these are the values which is on the bounding left, because if I go from this side and if I try keep finding out max at every position, it would always give me whatever is the maximum number I saw on my left before coming to me. And I can do the same thing if I go from here. So if I go here to 13, 13, so everything is basically 13. Yeah, wait. So everything is basically 13. Sorry guys, I'm using the tab years later. Finally got space for my tab in here. And it's not iPad, it's just a Wacom tab, which I think pretty awesome and pretty cool. And I don't know about Windows. Nobody cares about Windows, or I care about anyone who cares about Windows or Microsoft. It works out of the box with Linux. I remember for Windows I had to install some things. What else do you want, man? And before you start saying, oh, you must have been using Windows 10, 11 has support. I don't give a fuck. Thank you. Okay. Sorry, I really don't hate Windows. I mean, it's just not a great workflow for me. Specifically, if you're coming from Mac, it's not a great workflow for me. Okay. Okay, so yeah, basically that's it. So till here you would always find 13, which means that if I go from left to right, I would get the left bound, and if I go from right to left, I would get the right bound. I have to take the minimum of the left bound and the right bound, and then minus with the current height. And if this is greater than 0, this is when I need to say whatever the value is, or delta, into 1. That is the amount of water that will be stored on top. Yeah. And I always have to go from 1 to length -2, because on the other extreme sides, no matter what they have, they cannot hold water, because I'm guessing that it's just gonna like, so if I have two buildings on the either side and it actually rains, like 2 blocks, it's actually gonna just fall off the edge because there's nothing to bound on either sides, right? So yeah. The question here is, what is the height? The height is 1. Sorry, the height is 1. Sorry, the length is 1. So if you have length as 1, okay, now I'm actually getting sleepy. If you have length as 1, it's not gonna be anything. If you have length of 2, it's not gonna be anything. If you have length of 3 plus, that is when you can actually start looking for it. With 3 also, it should be very simple as, you know, this thing. But I mean, we can just generalize it into the algorithm. We don't have enough information that, you know, the value 3 is gonna come so much that I do not want to allocate space for it. So I don't want to write more extra code for that. It doesn't make sense. So let's do a general thing. I like this music actually. It's good. Now I'm kind of sleepy slowly. Yeah. I'm aged boys. 3 o'clock is the boundary now. 3 o'clock is the boundary. So let's quickly get this done. And yeah, we would be able to finish off one more. Awesome. What else? What else is required in life, bro? Just some validations from you. That's true. That is true. Okay. So in here, what I do want to do is I want to say, so you go from left to right, you find the left bound. At the same time, I can also run right to left and find the right bound. Int left bound y9. Okay. Int left is 1. So one of the things we can simply do is if length is less than 3, is simply return 0, length minus 2. Left bound of 0, क्या कर रहा है? Should be equal to this, and right bound of length minus 1 should be length minus 1, while left is less than equal to less than length minus 1. Left bound of left equals math.max, left bound of left minus 1. This is going to be within the range because we start from 1, and height of left. So when I go from this side, it's going to be the left bound, yeah, and right bound of right should be right bound of right plus 1, and this thing, and then I can simply say this right minus minus. Why are you? What is happening? Yeah. Okay. After that, what do we want to do? After that, the thing that we want to do in here is minimum of left and right. So again, for int I equals 1, I less than length minus 1, I plus plus. Math dot min, this thing, bound height. If bound height is greater than height of I, bound height minus this thing into 1. This in here, and return area. Question here is, can it go for a long? Wait, what do we return? We return an int. So that's pretty much it. This is probably completing because this thing. And how can I ignore? I don't see a way to ignore. Okay, never mind. That's explicitly for the compiler to move. For us, it's more like for understanding that, okay, it's height into width. The height difference into width would give you the block. So this is what is accepted right now. So let's quickly see if it accepts the other one. Awesome. We have another pink. We have another pink. Awesome. Can we have another last group of pink? This is the stack, which is quite a bit left. Binary, sliding, linked list. Linked list is also almost half done. There are a couple of left, so I don't want to go there. This also has some couple left. This one has couple left. Bit manipulation has 2 left. Okay. And 1 DP has 3 left. Intervals has 1 left, which is a hard problem. So let's maybe go here. Very, very simple. Let's go with what we cannot solve. And we didn't solve this before, so this is good actually. Okay. You're given a 2D array of intervals where intervals of I, left and right, represents the ith interval starting at left I and both are inclusive. You're also given an integer array of query points. The result of query point is the length of the shortest interval. What? You are also given an integer array of query points. Okay, the result of query J is the length of the shortest interval I such that left of I, if no such interval exists, the result of this query is -1. Wait, what? Is the shortest interval such that, okay, return an array where output is the result of query J. So what does this mean? 2. So is it sorted? Represents ith rest. Okay. So it doesn't quite say if it's sorted or not. So we have to take care of that, I think. The interval 2, 3 is the smallest one containing 2. Its length is 2. Acha. So, so in here, if I just copy this guy and that can also be 2.5. What is the issue? Oh, Java really has this weird ass stuff going on here. Okay, so in here, the expected output here is again 2. Why is it 2 though? Okay, so now if I say this is 5 and this is like 15, it's a valid thing. So if I'm querying 2, this lies in here. 1 and 13. 2 and 15, 2 and 150, let's say. So this 2 is good within 1 and 13 also, right? So in here, it would be 14. Why is it 13? 13 minus 1 plus 1. Okay. I'm doing 30 plus 1. Okay, for some reason. But anyways, okay. I get it. So you have a range of intervals and you have been given a number. If that number is comes within that interval, you consider it as a valid query, like a valid pick, and you pick it up. There can be multiple picks. Within those multiple picks, give me the least distance between the intervals or the least duration between the intervals, right? That's what we're looking at. Well, one of the things you can always do here is you can take each query and iterate over every one of them once and find out if they are like within the range or not. If it's within the range, you do some sort of a tag, basically keep it. So if this is n, this is k, you would have n into k, which is not really bad. So we can simply do an n squared solution, I feel, right? Because this is 1000, this is 1000, it would be 10 to the power 6. So not much of an issue. Not much of an issue. But before that, you also have to do a sort. Well, we don't have to do a sort, essentially. So let's first see if that actually works and like if you get a TLE. I don't believe we'll get a TLE, but the setup might be in a way where you get a TLE for 1000. So let's see. I'm sorry, I'll increase the sync bit in here. Slowly, all the companies are becoming shit. Most likely because they want people to leave and pump in more money into AI. That's true. Okay. So let's do what I just mentioned, right? Result equals query stuff length. So let's pick it up. For int interval of intervals. Well, for int I equals 0 in this thing. So you have that. So in here, one of the things you want to do is int min distance is integer max value. Wait a second. So this is always greater than this. And if there's no such interval existing, the result of the query is -1. So let's make it -1, because otherwise I wouldn't know if you actually have that distance, right? I mean, it still doesn't come in the range, but yeah. Okay. So in here, int query is queries of I. So interval of 0, query is greater than equal to this, and query is less than equal to interval of 1. Int distance or duration is interval of 1 minus interval of 0 plus 1. I have written this a couple of times to make a good mistake. So 0 is start, and this is the end. Wait, what the heck is that? And if min distance equal -1, or duration is less than min distance, we can simply say min distance is this. So if it was not set, you do that and you do that. Okay. So where do we stop? We stop here. Result of I should be equal to min distance. Return sub. So we do that, and again, in this particular case, you iterate over the number of queries. So let's say k, and then you iterate over the number of intervals. Let's say n. So it's n into k, or technically n square. Look at that, it got accepted. But the thing here is that these are very small. So it's 10 to the power 3 and 10 to the power 3. So it's going to be 10 to the power 6. But I don't know if the platform, again, this amortized values and things, look at that. It actually accepted my solution, right? So even n square solution worked. But let's try to see if we can actually, this has to be an n square solution. They recently introduced this, I suppose, but does it do a good job? Or yeah, it does a good job. Okay, does a good job, but the question here is, can I make it better? That's I feel the entire question, and most of the question is, you know, picked from LeetCode. So let's see. Okay, let's see what LeetCode has. I didn't solve this either. This is the problem. So this will not run in here because it's 10 to the power 5 and 10 to the power 5. So that's the thing. Because if I run the same problem in here, submission. If I see the code, and it's basically, I probably copy paste this entire thing. It runs, but then this will be a TLE. This is gonna be a TLE. We know for a fact it's gonna be a TLE, and it kind of failed at quite far off. It's not even like very nearby, right? So that's one thing to take care of. The question here is, what do we do? What do we do? Okay, so let's try and think of a different solution where it's a little optimized. So one of the things which comes to my mind with queries is that you do segment trees. I've never learned segment trees, so that's one of the things in algorithm R that you should be learning about segment trees. I think it's called bit trees or something. Can I just go here? Can you just give me dark? Okay. Can you give me automate? Thank you. I'm sorry. Yawning. Now I'm actually sleepy. Yeah. Let's actually look at the hints if you have one. Okay, so first of all, I want to look at the companies. Of course, Google asked, and then Amazon asked it before. I don't really know if these are correct data, but yeah. So if I look at the topics, what the fuck is a line sweep? You have a... What the heck is a line sweep? I don't know what's a line sweep now. Anyways, it also talks about priority heap, priority queues. I'm not quite sure what you do with the priority queue. In here, what can you do with the priority queue actually? Anyways, let me just think through how we can do this. So as I already previously mentioned, that I think we can do sorting, and once you do sorting, you can also somewhat do a binary search on it, but you have to do a binary search on two sites. That the value is within that range, and then the value is not within the range, right? But it's not really helpful because there can be a range on the right hand side 5 to 7, and on the left hand side a range would be 3 to 30. So your range would be bigger in that case. So all the numbers would not be like, let's say 5 to 7. Yeah, no, it should be taken care of, right? So I feel it's a two-dimensional data. On the right hand side where I fall, on the left hand side where I fall, and between will I be falling in all the intervals in between? I feel like so. You know what? Before solving this problem, I'm gonna take a quick break. I'm already yawning, so I'm gonna take a quick break of 5 minutes. And meanwhile, I'm also gonna think this problem through, and then come and try and solve this. Okay? And yeah, it's already 3 o'clock in my time. And I'm just gonna be sorry. I'm just gonna be doing this as the last. I feel, yeah, this is the last one. Let me look at the... I don't want to look at the hints. Okay, so let me take a quick break, and meanwhile I'll actually try and see if I can come up and think of a way where I can solve this, how I can solve this. Yeah, so yeah, let me take a quick break. Thanks. Okay, so we are back. And yeah, let's quickly see how we can solve this problem. So there's no guarantee that this is sorted. Yeah, there's no guarantee that this is sorted. Okay. So yeah, this is also not sorted. But if I sort this thing, I mean, I can sort it manually, right? I can sort this manually, where I can say, okay, this is 1, 8, 2, 3, 2, 5, and 20, 25. So, wait, this is not where we are solving. 2, 19, 5, 22. 2, 19, 5, 22. So what we can simply do here is first sort these values. We sorted them, and that should be fine because we are still within that bound of 10 to the power 5. So let's go back here, 10 to the power 5. Yeah. So this lookup has to be some sort of a log n lookup, I would say. We cannot keep popping things out because even with this range, this thing will come in. This thing will come in. Because if I see 2, then I have to pop all 3 of these. Then with 5, technically this is the smallest one. But how do I figure that out? For this is the smallest one. If I do a binary search of this thing, that where exactly it lands on this side, it will be within the range. In here, if it's within the range, it's a good value. And what I can say here is that because it's within the range, I can simply say that this here is a left pointer. So I'm doing a binary search for every one of these. This is a good pointer. And this here is another good point. So for 2, I would say, oh, this here is good. This here is bad. So I'm going to move this pointer here. So it's going to be 2, 5. Now, for a matter of fact, I know that since this is 2, and this is also within the range, we should be good here. But then, technically speaking, with the flow, I should be moving. This is here. So I should be moving the pointer here because I want to find the rightmost interval in which it lies. And that is supposedly a problem because it's going to oscillate now. So I don't want to do that. So remember there's some hints there. Maybe I can look at the hints. Is there a way to order the intervals and queries such that it takes less time to query? What kind of a hint is this? Is there a way to add and remove intervals by going from the smallest query to the largest query to find the minimum size? This is the more interesting part. Is there a way to add and remove? So it's not only about removal, it also has to add something back. which also means I need to keep a state of what is being removed, and I add that back. Oh. Not quite sure. Not quite sure. So what exactly can be the case in here? What if I reverse the problem? What if I go over every single interval and I find a range? So if I sort this thing 2, 5, 19, 22. So I'm here 2 to 3. So I have to find all the numbers between 2 and 3 in here. And I can find that using binary search. So 2 is here. And then for 3, I'm gonna have to find, yeah, so I don't have anything here. So I don't care about that. So this can be the solution. So it's 2. And is it part of this? So 2, 5, 19, 22. So here I can say for 2, the minimum is 1. Then I go to 2 and 5. So 2, I land up here. And then for 5, if I try and find the smaller equal value, it lands up here. Then I have to iterate within this and say, oh, 2, it's not. For 5, there is nothing, which means the minimum is, so we can always keep as -1. So the minimum here is 3. 5 minus 4. 4 is the minimum. Then I say 9. Then I go here 1 and 8. So for the lower value, it's going to be greater than equal, and for the upper value, it's going to be less than equal. So again, I'm going to be landing here and here. So again, I have to iterate over this. For this, again, I would be having 20. So greater than equal to for 20. So it's going to land here. And then for 25, again, it's going to land here. So 22. So yeah, 22 is going to be 6. Is that the answer? 2 minus 1, 4, 6. In this particular case, we have to still again maintain the order that we actually did that. So let's try and do that and see how exactly it's going to fare. Because it's going to be O of n solution, O of log n solution, O of n log n solution, and I think that should be okay. But let's see if it fares. Okay, so what do we do? That's pretty much it. So for int interval in the thing, we call it left and right. So let's do that. Int left bound is, so we need a method find index greater than equal to. So array int target. If array of mid is greater than equal to target, so this is what we want. So this is what we want. First, you have to do that. Index is mid. Wait. I did something wrong in here. Yeah. This is this. Values and left. Right bound. It's gonna be less than. Private int find less than int target. You can copy paste some of the code from here. Okay. So now what? If array of mid of 0 is now less than equal to target, so yeah, right is this. If left bound not equal to -1, int result is new length. So what now? It is not -1, which means I found it. If int index equal values of if left bound not equal to -1 and right bound is not equal to -1. So here's the thing. What if one of them is found? It won't be possible if I'm not wrong. Huh. I feel I'm doing wrong. Let's see. I'm pretty sure this is wrong, but okay. Uh, Man, I'm really, really sleepy now. So, uh, some. Wait, why is everything zero? Ah, I know. Okay. The solution is right, but it does a TLD. Because if I take the solution and stick it in here, and if I just do a run and a submit, it works fine. Time complexity is definitely not. Wait, what? Why? Okay. I don't understand a single bit to this, honestly. Mm, but don't want to look at the solution. I mean, this one yet. Oh, there's something called sweep line algorithm. I was not aware of that. Okay. This is exactly what I was talking about, a segment tree. A segment tree. Hmm. Okay, so first of all, I think what I'm gonna do today is I'm not gonna actually, like, I kind of got the gist of what you do, but I'm not gonna solve it today. I'm gonna solve it tomorrow. Specifically, if I solve it now, it just, quickly comes up in the head, and yeah, so I'm gonna solve it later on at some time where, um, like I forgot. uh, yeah, so that is basically it. Uh, that's basically it. And if you guys are interested, I'm gonna leave this in the chat. Yeah, I don't know what to do about this. Where is chat? Why can't I see the chat? Wait, did I already go offline? No. What is happening? And how is my stream looking, by the way? And the stream is looking fine, but it's kind of lost the color on my camera. Wait. I'm a dummy dum dum. I'm a dummy dum dum. Okay, my bad. Okay. Okay. Anyways. Okay. Yeah. So as you can see already on my face that I'm already kind of drowned in sleep. So what I'm gonna do is go get some sleep. And yeah, thank you so much for joining. Hope it was a good session. Hope it was a productive session. Hope you learned something. And yeah, like I mentioned, this algorithm R is gonna be continuing here and there, and I'm gonna be doing live streams. I'm gonna be doing other things. So just by the way, since I already saw this, I want to reduce this a little bit because my face is kind of big in the yeah, it's kind of big. Yeah, that is pretty much okay. I would say this is okay. Cool. Anyways, I didn't like my own stream. I should. Okay. Anyways, thank you so much for joining. It's already 3:30. I'm gonna get some sleep now, and so the plan now is that if I do a live stream, it's gonna be anytime in the week, depending on if I get time. But Fridays and Saturdays, I'm definitely gonna try and stream. Sunday is gonna be my personal time, so no streams on Sunday unless I just do a stream in the morning. Again, I don't want to keep any schedule. I'm just gonna do a stream when I think that okay, it's a good time to stream, and yeah, that's pretty much it. So, and the most important thing is that this algorithm R is going to be one heck of a long series where I keep on doing algorithms. I won't come up with a different name, that's for sure. You can see in the thumbnails, the only thing that will change is the only thing that's going to change is my like what is that called? Down you have this grinding late night link for and things like that, right? So that thing will change. Other than that, yeah, nothing else. I'm gonna keep it calling algorithm hour. And yeah, that's pretty much it. That's pretty much it for today. For tonight. Okay, it's already like past the devil's hour. So I'm gonna get some sleep. I'm gonna wake up super late tomorrow because it's Sunday, and most likely I won't be streaming. But from next week, I'm gonna be making a time that Friday and Saturday I'm gonna be streaming, and rest of the days I'll be mostly working on my own software, like on my own time and offline. And if possible, I'll be recording videos. That's basically the entire idea, and let's see how it goes. And yeah, so like I mentioned, one of the things that I wanted to talk about is well, I'm not going to talk about now. Probably going to make a video tomorrow, and yeah, I think I'll publish a video about that where I'm going to start a new series. I'm going to start a full stack app, try to build a SaaS around certain thing, what exactly it is and what exactly it is not. I'll be telling it tomorrow or like whenever the video comes out, maybe sometime by next week. And very soon I'll be starting to work on that. And there's going to be some new technology learning things there. So let's see. And hopefully it's going to be good. Okay, so thank you so much for joining. Everyone who joins, thank you so much for tuning in. And have a good night or a good morning or wherever you're watching from. You have a good day, buddies. Thank you so much. Bye bye. And do like, share, and subscribe to the channel. It helps. Thank you. Bye.